Hi guys, this is video 2 of quadratic functions. I'm gonna try to do an example here that many people tend to find very hard to do in their exams. For example, in this question, you are given y is equal to x squared minus 5, and the question is asking us what should k be such that y has only one real root in y is equal to x squared minus 5 plus k. So what should that k be so that the function is only one real root? What does it mean for a function to have one real root? I think that's the most important question before you attempt to do the whole question. So first of all, I will try to introduce you to the concept of roots. Imagine you had a parabola that touched the x-axis only once here. We would say that it has one root. And then if you had a parabola that touched the x-axis twice, here and here, we would say it has two roots. And if you had a parabola that didn't touch the x-axis anywhere, we would say there are no roots. So basically what you're seeing here, based on the explanation I've just given, is that the roots of an equation are those parts of the graph that touch the x-axis. I mean, it's the x values of the parts of the graph that touch the x-axis. So the parts of this graph that touch the x-axis are these here. The x values that you would find there are called the roots. That's just a basic explanation so that people understand. There is a very formal definition for what a root is, but then in this video I'm trying to help everyone get the picture. Okay, so let's continue. So now that you have this knowledge, we can confidently attempt to do this question. Okay, so what should k be such that y has only one real root? For y to have only one real root, it would have to take this, it would have to meet this criteria. If you look at this function here, it's a parabola as well, and it only touches the x-axis once. This means that it has only one root. So let's first draw this function and try to see if we can make it look like this one. Okay, I'm going to draw it here. This function would look something like this. And this is c. Remember guys, this is c. It's going to be, let me write it here. This is c. c is equal to -5. Let me just, okay, remember from the general expression, from the general equation, y is equal to ax squared plus bx plus c. Here there's a coefficient of 1 here, even if it's not written, it corresponds to that a there. And then there is no expression with an x in it, which means that b is 0 here. And then there's a constant c which corresponds with -5 there. So we can clearly see that c is -5 and a is equal to 1. So now that we know that this function here is exactly this one, it takes this general form, we can then use these characteristics to study what ought to happen such that the criteria in the question is met. So for this function to have only one real root, it would have to go upwards so that it only touches the x-axis once for us to get one real root. But then by how much should this function go upwards? It should go upwards by 5 units. So we know that it has to go upwards by 5 units. But then this is not very helpful in the sense that we are solving by inspection. Is there a way that we can use to solve these types of questions in whatever scenario, no matter how complicated the function is? The answer is yes. If you look at this function here, this negative 5 plus k, that negative 5 plus k, that whole thing there is c. Remember, this is x squared. X squared corresponds with ax squared, where 1 here is that a there, and then bx is not present here, but c is the constant that remains. So if we have negative 5 here plus k is simply just a number that when added to 5 will cause the function to go up. So basically k is that 5 units there, but we did that by inspection. What we want is to know the exact is to find what we want to know is what I would call a reliable way of finding k. So what is c going to be here? C here is going to be equal to 0 there. So what you can do is that you can just say negative 5 plus k is equal to c, but then there c has to be 0, so negative 5 plus k is going to be equal to 0, and then you can then now solve for k. Negative 5 comes to this side, it becomes positive, so therefore k has to be equal to 5 such that this function is only one real root.